Day 739 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1665, minimum initial energy to finish tasks. The difficulty level is hard, but don't worry because you already know we're about to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You're given an array task where task of I is actual I and minimum I. Actual I is the actual amount of energy you spend to finish the ith task. Minimum I is the minimum amount of energy you require to begin the ith task. For example, if the task is an array of integers 10 and 12, your current energy is 11, you cannot start this task. However, if your current energy is 13, you can complete this task and your energy will be 3 after finishing it. You can finish the task in any order. Return the minimum initial amount of energy you will need to finish all tasks. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, our input task equals a 2D array of integers. First array is 1, 2, next array is 2, 4, last array is 4, 8. The output is 8, so that means that 8 is the minimum initial amount of energy we need to finish all tasks. So let's look at the explanation to see what they mean by that. So, we're starting with 8 energy. We finish the task in the following order. So we have 8, we start with 8 energy, right? So that means we can start all of these tasks, but we are going to start with the third task because remember, minimum is the minimum amount of energy required to begin that task, and that would be the value on the right side of the array, right? There's only 2 values, so this would be this side is the minimum. This is the amount of energy or the minimum amount of energy we need to get started, and then this side, the left side, is the actual amount of energy we need to spend to finish the task. But we still need 8 amounts of energy to start this task. So since we're going to start with 8 and we're going to complete this task. After we complete this task, since it takes 4 amounts of energy to complete the task, we start with 8, right? We start with 8, then we spend 4 energy. Now we're left with 4. Boom. Then now we have 4 left. We can start this task because this task, remember, requires 4 to start, right? Boom. The minimum I is the minimum amount of energy required to start. So since we have 4, we're left with 4 energy after completing this task. We still have 4. We can complete this task. After 4, we start this one. We do 4 minus 2 equals 2. Boom. Now we still have 2 to finish this task. Boom. Then, not to finish this task, but to start this task. Boom. Then once we start this task, now we do 2 minus 1, and that's going to equal 1. And we were able to complete every task. It says, notice that even though we have leftover energy, starting with 7 energy does not work because we cannot do the third task. All right, y'all, so let's take a look at example 2. So in example 2, our input task equals a 2D array of integers 1, 3, 2, 4, 10, 11, 10, 12, and 8, 9. This time the output is 32. It says starting with 32 energy, we finish the task in the following order. So first, we're going to do the first task, which will be this right here. Boom. So after we do this, we start with 32. We use 1 energy. We needed 3 to start, but we had 32. Once we started, we use 1 energy. Boom. Now we're left with 31. Once we have 31, we can start this task. So we start this task, then we do minus 2. Remember, it says 4. That means we need at least 4 energy, but we have 31 energy, so we could do this task. Then that's going to take two amounts of energy, so 31 minus 2 is going to be 29. Now we have 29 energy left, and we are going to start the third task because it only needs up to 11 energy. So we start this, then we do 29 minus 10. That's going to leave us with 19 energy left. Then we start this task. This task is going to take 10 energy, so 19 minus 10 is going to equal 9. Then 9 is just enough to start this task, and that is going to require 8 amounts of energy. But after that, we'll still have 1 energy left, and 32 was the minimal initial amount of energy you will need to finish all tasks. Boom. Now let's take a look at example 3. So in example 3, our task equals a 2D array of integers. First array 1, 7, then 2, 8, then 3, 9, then 4, 10, then 5, 11, then 6, 12. Our output is 27. It says starting with 27 energy, we finish the task in the following order. So we start with 20. This time, we're not going through the task in order like we did before. This time, we're going to have to pick and choose which task we do first. So first, we're going to do, so let's see, one moment, y'all. So trying to see, we start with 27. We got 1, 2, 3, 4, 5. Oh, 6, sorry. That's what was throwing me off. I didn't see the 6th task right here. Okay, boom. So we start with 27 energy, right? We do the 5th task. Boom. So we do the 5th task. So that's going to take 5 energy from us. So 27 minus 5, we're left with 22 energy. After 22 energy, we're going to do the 2nd task right here. Boom. After the 2nd task, that's going to take 2 from the 22, and now we're left right here with 20. Boom. So we have 20. Then from 20, we're going to do the 3rd task right here. Boom. That's going to be 20 minus 3, right? That's going to leave us with 17. So with 17, then we'll do the 1st task. Boom, right here. Boom. So after that, that's going to be 17 minus this 1 right here. That's going to leave us with 16. Boom. Then from 16, now we'll do the 4th task. The 4th task is going to be 16, or this 16 minus this 4 is going to give us 12. Boom. Then we could do the last task, or the 6th task right here, because we have 12 energy. So we're going to subtract this 6 from this 12. That's going to leave us with 6. But in the end, 27 was the minimum, right? We want the minimum initial amount of energy we'll need to finish all tasks. So boom, y'all. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Boom. First thing we're going to do is we're going to sort the task by the difference between the minimum required energy and the actual energy consumed. Tasks that require a larger buffer of energy are handled first, and this greedy strategy is going to minimize the total starting energy. So we're going to come right here. We're going to say let tasks equal task.sorted. Open up the brackets, and we're going to open up the parentheses, and we're going to say $0 square bracket 1. Sorry, y'all. Minus $0 square bracket 0 is greater than, open up the parentheses. Sorry, y'all. This should be in parentheses as well. This right. Oh, we should have closed these parentheses right here. Sorry. We can get rid of this. And then these parentheses, we're going to say $1 square bracket 1 minus $1 square bracket 0. Boom. Then we're going to track the total initial energy we had to add. So we're going to come underneath this, declare a variable called energy needed, and we'll set that equal to 0. Then we're going to track the current available energy while processing tasks by declaring a variable called cur energy equals 0. Boom. And then we're going to process each task in the optimized order by saying for task in task. Sorry, y'all. This should not have an S. We are going to open up the brackets. And so actual is the energy spent to complete the task, and then minimum will be the minimum energy required to start the task. So we're going to say let, open up the parentheses, actual, comma, minimum, come outside of that, and we're going to set that equal to, open up the parentheses, task, square bracket 0, comma, task, square bracket 1. Boom. And if the current energy is less than the required minimum, increase our starting energy enough to meet the requirement. So we're going to come underneath this and we're going to say if current energy is less than minimum, we're going to open up the brackets and add only the missing amount needed by saying energy needed plus equals minimum minus current energy. Boom. Then we're going to update the current energy to the required minimum by saying current energy equals minimum. Boom. Then we're going to complete the task and spend the actual energy cost by coming underneath this. And we're going to say current energy minus equals actual. Then we need to return the minimum initial energy required by coming underneath this. And we could just say return energy needed. Boom, y'all. That's all she wrote. Let's give it a run. Make sure it runs properly before we submit it. Ooh, we got the wrong answer. So that means somewhere probably got the math wrong. Let me check. It's not that much math to get wrong. So give me a minute. Oh, here it is. This right here should be a plus equals, not an equal equals. So now let's give it a run, see if that did the trick. Let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 13 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.